Another week, another new Ediacaran Lagostata. This one could be really special, as it seems to be a transitional fauna between the Ediacaran and the Cambrian, including bilaterians. Although it has limitations. As you know by now, I'm not afraid to question or challenge interpretations if I think they need it, and so don't expect me to be completely uncritically accepting of this one. That said, it certainly is very intriguing indeed. Hello, and welcome back, or possibly welcome for the first time if this reaches a bigger audience than normal, we'll see. But if anyone is finding me for the first time, I'm a paleontologist, and Lucy, who pops up every now and then, is also a paleontologist, and we tend to do deep dives into particularly quite early animal life, Ediacaran, Cambrian, Ordovician, that sort of time period. And when I say deep dives, I mean really trying to understand new papers, ideas, disputes or difficulties in our understanding of the history of life, and see where the arguments really take us. So, first off, a big thank you to Ulf, who's a science journalist, for putting me in the loop on this one a couple of days in advance, so that I had some notice and could prepare something for when the press embargo dropped. I had no idea this was coming, despite the fact I know a couple of the authors, but it is obviously one though which has been kept fairly well hidden, and it looks amazing. It's published in Science, which is one of the top journals, and it appears at first glance, and certainly my impression at first glance when I first flicked through the figures was, wow. We've kind of been looking for something of a holy grail. Between the Cambrian and the Ediacaran, there's a bit of a gap in our knowledge of soft-bodied faunas, just when animals seem to be diversifying into the modern phyla. So we have amazing deposits all through the early Cambrian and, well, later in the early Cambrian, and we have some really good ones in the Ediacaran, but that transitional interval is more difficult. I did a video a little while ago about the Jiangchuan Biota, which starts to fill this gap, but there were no obvious bilaterally symmetric bilaterian animals. It was much more like the end of the Ediacaran. And yet, most of our ideas predict that there should be diversification of many recognizable animal groups in the latest part of the Ediacaran, at least, if not much further back. So, we need more faunas, and what we've been lacking is one that seems to show these animals. Now, I will warn you in advance that there are parts of this I am not convinced by. But there are also parts that are seriously intriguing. So let's have a really close look. This is the paper. It's The Dawn of the Phanerozoic, a transitional fauna from the late Ediacaran of southwest China. So the author list is fairly long. It includes some well-known names in there, and Luke Parry and Frankie Dunn and Payan Song, Ross Anderson. Yeah, there's lots of people we know. And Luke Parry especially is really quite prominent in this field. And it sounds really exciting to start with. This is exactly what we've been waiting for a long, long time. Southwest China, in this case, is near Kunming in Yunnan province. And it is a rather rich area for fossils in general, because this is not too far away from the Jiangchuan Biota and many others. This whole region seems to be absolutely full of conservat lagostatin, and especially from the Ediacaran-Cambrian interval. Now, in terms of the age, this is actually quite a critical thing. Anything where we're looking at the Ediacaran to Cambrian transition, it's really important to get the age pinned down as far as you possibly can. And especially in the Ediacaran, it's quite difficult. Once you get into the Cambrian, there are many other fossils that you can bring in to try to work out the relative ages. But in the Ediacaran, it's harder. So they have constraints on it. So we know that in this area, the base of the Cambrian is assigned to or correlated with the base of the formation overlying this one. This fossil assemblage is in the Dungying Formation in the Jiangchuan member, and this is dated around its base at 554 million years. The base of the Cambrian is about 538.8, so 554 is quite a long way below. There is another ash bed dating it in the middle of the member at 546. This is now getting quite a lot closer. That's only 6 million years before the base of the Cambrian, as recognised in this area. And there are additional constraints as well, because there is a little fossil called Shanxi-lithes, which is a little tubular thing, slightly problematic. And this occurs quite widely across South China, and the last occurrence is substantially below the beds with these exceptional fossils in. So it is younger than the last occurrence of Shanxi-lithes, and it appears to be near the top of the Jiangchuan member. However, there are no absolute dates in this area between that middle of the Jiangchuan member and then the top of that member through the whole of the last member of the Dungying Formation until you get to the boundary of the Cambrian. So because sediments can be deposited at very different rates, you can't just look at it and say, well, it's near the middle of that sequence, so therefore it's near the middle of the age range. It doesn't work like that. So we don't actually know for certain whether it is close to 546 or much closer to the base of the Cambrian. The other problem is that that date for the middle part of the Jiangchuan member is based on an ash bed that occurs in another section where this fauna does not occur. So although you can correlate by rock type, that can also be ambiguous, and it seems to be a little unclear whether it really is above the 546 million years date. My impression is that it almost certainly is, but because you can't directly correlate the fossils within the same section with that ash bed, they can't be entirely sure. So they're dating it as it must have been between at least 554 and 539 million years, and possibly between 546 and 539. This is actually quite important because it's this sort of detail that allows us to tie in the relative ages with other biotas, such as the Tangshan biota. Now, this is the one that includes some of these Ediacaran fronds and various other typical Ediacaran creatures, but didn't contain any obvious animals, as I would recognize them anyway. And in this case, we have a correlation diagram where they've got lots of dotted lines, but it's illustrated here in their figure 1 as being more or less the same range as the Tangshan biota. It's a sort of lateral equivalent based on this. But that includes all of the uncertainty. So going back to 554 million, if you were to take this at 546 million onwards, then it only overlaps with the last part of the possible range of the Tangshan biota, which is also similarly not well constrained, and then goes quite a long way through up towards the base of the Cambrian. So it could well be, given these overlapping ranges, that the Tangshan biota is significantly older than this one, the Jiangchuan. And there's actually good evidence for that as well, in that I mentioned this Shanxi-lithes, and this is much lower down. It's significantly below the level that we get the fossils at here. The last occurrence of Shanxi-lithes happens, and then you get these fossils. In the Tangshan biota, Shanxi-lithes occurs something like 8-10 meters above the Tangshan biota. So it looks like the last occurrence of Shanxi-lithes is younger than Tangshan, but significantly older than the new Jiangchuan biota. So it's probably closer to the Cambrian boundary, is what we're saying, but there's no way of being absolutely precise at this stage with the exact correlation. The paleoenvironment is not really discussed in great detail in this paper, but it's quite a complex section. So the lower part of the sections are composed mainly of sort of muddy dolomites, sort of limestones with dolomite in, and That then grades upwards into sort of siltstones, shales, sandstones, and it seems to be quite a variable environment. They say in the paper that the interesting fossils are preserved in mudstones and siltstones, which they believe were from event beds, and quite often they are preserved at the base of these event beds. So you've got rapid burial events, which is carrying lots of silt or mud in. Doesn't say how thick these beds were, but within those you get these fossils. There are also layers with trace fossils, but these are not the same horizons as you get the body fossils. This is not too unfamiliar. It's quite a common pattern that you get things preserved in different layers because different sedimentary processes tend to preserve trace fossils versus body fossils. So that's no problem, but they do have these two assemblages which are separate. Now, one thing that's really important to note is that this assemblage is not new. The fossils, or the knowledge of fossils in these sections goes back, or in some of the sections, goes back to the 1980s, where it is well known as a site with abundant algal material. Not particularly diverse, but there is a range of algal fossils, typical Ediacaran things, longfunction, that sort of stuff. This has a long history of study. But what they have now are, first, an additional section, and second, what are in almost all cases, we'll come back to this, extremely rare examples of animal-like fossils that have appeared as ones and twos within extremely abundant algal material. So you have hundreds or thousands of algal specimens, and then there's a few of these fossils. With one more common exception, don't worry, we'll come back to that. But it is also worth saying that they say that the algae and the animal fossils occur on different horizons. It's extremely rare to get an animal mixed up with the algae, which is interesting. There's some sort of segregation going on there. It's also a little bit strange, you might think. Why would the algae not be preserved alongside animals? Not sure. But there are complexities in the distribution of fossils here. And we don't have really fine resolution of exactly where each of these fossils came from. It seems to have been on a very fine scale, given that you can't distinguish them based on the log. Okay, so what are the fossils? Well, I mentioned algae, and they have a lot of algae. They don't focus on this. There's a supporting figure showing them, and they're very nice things. You get all sorts of discoidal type blobs, which are quite common at this time. You get ribbon-like things, and you get these little blobs on stalks, which are also very common. These are the sort of longfunction. There's a range of taxa represented here, and they just illustrate a few of them. But these algae are very common. And the preservation, if you look at this sort of rock type here, it's black films on a quite coarse sort of silty matrix. It's very similar to many of the other algal lagerstätten that you get in the Ediacaran of China, the Jiangchuan Biota, for example, Miaohe. Lots of similarity here in the preservational style, the sort of black carbonaceous films, and in the sediment that they're preserved in. One thing I think it's important to appreciate about all these algae is that algae are quite fragile, delicate things, and when they're washing around, they can deform and appear as shapes that are slightly different from what is familiar. And I think this has happened in a previous paper from here, where there was a fossil described as Alienum. Alienum? Not sure. But it is a peculiar thing which appears vaguely, superficially similar to the weird Cambrian group, the Coillections, and those similarities were talked up quite a lot in this paper, where it was described as a probable bilaterian, can't remember the exact phrasing they use now, and probably with affinities to the Coillections. However, I'm pretty certain, unfortunately, that that is one of the end members of the distorted versions of the longfunction. If you go looking for papers on longfunction, then you do see that there's a wide range of variability in them, and some of them can appear slightly more square with a little sort of stalk coming out one side, and you turn it that way around, and you end up with Alienum. And if you have thousands of specimens of algae and you have one outlier which looks more animal-like than the others, I think it's something one you have to be very, very careful with. It's very easy to see something which is superficially at least more animal-like and then interpret subtleties in the thickness of the carbon film as much more definite structures to support an opinion. So this is part of the reason why we have to be careful, because what we're showing here are the rare examples of these animal-like fossils, and then we're not seeing the hundreds or thousands of algal-like fossils. So let's have a quick tour of what they've got to start with, and then go back and discuss some of them in much more detail. First off, they have some Ediacaran-like organisms, including a thing that resembles Hautia. This is a strange one. Hautia has been interpreted as a Nidarian and is characterized by lots of bundles of fibers all over it, which are considered to be muscle fibers. It's quite different in that it only has 2 spikes on the side rather than 4, but biradial symmetry is plausible for Nidarians, they say, so, they think this is closely related to Hautia and is a Nidarian. They also have something here which they are interpreting as a ctenophore, which is, according to quite a lot of work now, probably the first animal phylum to diverge from the others, so you would expect ctenophores at this time if the animals have diversified. They've got a thing called a Mackenziid, they say, or 2 specimens. I think that's actually the 2 overlapping each other. Can't see much detail in that one, but it's a thing. And then there's this circular thing with a very approximate triradiate ridge on it, which they're interpreting as a trilobozoan. Again, another typical Ediacaran group. Then it gets onto the bilaterians. And this is where it gets really unexpectedly interesting. Or this is what we've been waiting for, is things that look like bilaterians. And on the one hand, we have vermiform organisms with an invertible proboscis. This is how they're described, but with a peculiarity of them being attached to a great big sucker disc at the bottom. So they are elongate, they have a sort of fluffy termination, and then there's a bit sticking at the end. Interesting. We will come back to this. This is the only common species of animal in this assemblage. So that's quite an interesting thing. They've got well over 100 specimens of this. They have, in contrast, a single specimen of this, which is, they interpret as a worm as well, of some sort of vermiform organism, with one end showing a circular possible mouth. Interesting. Again, we'll come back to this. There are at least a couple of tubes which look very similar to a thing called Margaritia, which is well known from Cambrian deposits, originally described as an alga, now generally thought of as a tube made by enteronuced worms. So this would be crown group hemichordates. And then there is this, along with 3 other specimens of things that they are interpreting as cambroernids. These are generally thought of as stem group ambulacrarians, so hemichordates plus echinoderms form a group, and the branch leading to that group consists of weird things that are known as Herpetogaster, Phlogites, various other organisms of which are a bit stranger, disc-like things. But this looks like a Herpetogaster. They've got this weird sort of curved body, a stalk going into the bottom, and tentacles. Interesting, because this looks like, at first glance at least, something which is definitely a crown group animal, definitely a bilaterian, and in fact definitely a deuterostome, is how it is currently interpreted. And to have a deuterostome in the Ediacaran, that is a big step forward in our knowledge. If this is true, that's very important. Now, this is a table of the number of specimens of each of these groups that they've got. So there's 3 of them with only 1, the radialomorph, the potential ctenophore, and the sausage-shaped vermiform animal. Then you've got a couple with, well, you've got one with two, the Mackenzie-like specimens, which I'm not going to do any more with because it's difficult to say much from what's seen there. Then you have 4 Cambroernids, these Herpetogaster-like things, 4 Margaritia-like tubes, 6 Hautia-like specimens, 15 trace fossils, and 185 of this sessile vermiform organism. So some of these are very low numbers, which is fine if they're really good specimens where you can see all the detail you want to in the one specimen. If they're not so good, and you're not even totally sure whether things are the same thing, that's more of a problem. But let's have a look at some of these in turn. So I'll start with some of the least convincing and work my way upwards. So let's have a look at that ctenophore first. Now, a ctenophore would be really important because of its status as possibly the first animal group to evolve, animal phylum. So there's a lot of speculation about their earliest ancestors. There's a lot of interpretation of weird fossils which appear to be benthic, things called sclerotenophores in the Cambrian, where you have sort of slightly skeletonized ones. And their main feature is a series of comb rows, which are used for locomotion especially. Now, this thing here is being interpreted as a ctenophore on the basis of 2 main features, I think. And you got the overall shape, but there's not much to go on there. It's basically a sort of elongate, rounded thing. But the 2 main features are this part labelled OS at the top, which is a circular structure with lines going across it in various places, almost toothed edge. And then at the bottom, you have the bits labelled CT. We'll come on to that in a minute. But this circular structure, unfortunately, to me, it really doesn't look promising at all, because in this type of rock, this sort of white weathering black mudstone, in the early Cambrian of South China, in the Jiangchuan Biota, for example, and even in similar sort of rocks in the late Ordovician, where you get them sort of weathering in this way, what we found is that concretions, which are often originally pyrite, but are totally weathered, end up looking exactly like this. So you've got this range of different colours here. It's basically white and yellow in comparison with this sort of reddish colour over the rest of it, or orangey. The other thing is that these sort of tooth-like structures, which is considered to be the oral skirt, so a ring of almost feather-like plumes in some species that surrounds the mouth area. In this case, you can actually make this out that they are constrained by a series of parallel lines in 2 different orientations. And those parallel lines, sort of like that, are kind of what you'd expect from the fracturing pattern of concretions that are weathering under a regional stress regime. And we see this very, very commonly again in these concretions in other deposits in the early Paleozoic of China. It's also very high relief in comparison with the rest. The yellow would be something like siderite, not siderite, sorry, various iron oxides, maybe it is siderite, that produce a range of colours, including this yellow. So I think that is a highly oxidized nodule with internal cracking structures, giving you what appears to be these separate structures around the edge. So I don't think you can put any weight on that, which means that we are left with the other end. And this is this one small sort of blow up here. You can see there are a series of parallel lines going across it. You can also see that there is relief to it, and there are multiple sort of relatively high relief surfaces with angles going between them, and these are considered to be the comb rows, the teens of the ctenophore. Now you can see traces of similar patterns possibly going further up. It's much fainter as you go up through the into this wider angle view, but I think you can see there are transverse structures going across here, but there's also a series of linear longitudinal structures that they are sort of diverging away from. So, is this a ctenophore? Well, it is one of the things that has these transverse structures in it, but another one which is probably much more plausible in this case, based on what I can see of the three-dimensionality and the form of it, is a conilariid. Now, these are one of the few well-known groups of Paleozoic metazoan fossils that do go back into the late Ediacaran. They've been found in China and in Brazil, and they are probably Scyphozoan Nidarians. They're certainly, well, the consensus is they're almost certainly Nidarians, and they fit best within the Scyphozoans, so jellyfish and allies. And they have a mineralized phosphatic, well, organophosphatic test, which is pyramid-shaped with panels down the side and transverse ornament going across them. And to me, from what I can see of the shape of this, that is much more likely to be something like a conilariid than it is a ctenophore. I do not see any reason why you would call that a ctenophore. So for me, I'm kind of ruling that out because I don't buy it for a minute, I'm afraid. Sorry about that. Let's go on to the next one. On the same slab, we have this thing here, this circular structure with a triradiate sort of marking on it, but with lots of little smaller ridges coming off particularly one of these branches. The three branches are themselves a little bit irregular. They're different in size and thickness and length. And in the text, they actually say there are 4 branches which are uneven in length, but I'm not seeing that at all. I'm seeing 3 with lots of little side branches coming off here. Now, there are also little wrinkles, which are concentric ones in the lower quadrant especially, that are visible. And I mean, it's been described as a possible trilobozoan, so one of these things like Tribrachidium or something like that, these peculiar Ediacaran things. So it's not out of place at this time, but is it that? I'm not sure. I think with only one specimen, I would be very suspicious that this is actually one of these globose carbonaceous films of algae. Things like Chuaria, for example, which are well known, very common at this time, which has been compressed in such a way to give you a threefold wrinkling pattern and then lots of irregular wrinkles as well. I think this is possibly one of the anomalous end members, just the way that this thing has been compressed in this particular specimen, making it look like something else. So I don't put much faith in that either, I'm afraid. But there's one specimen of this and one of the ctenophore. If you had multiple ones, you'd be much more confident on what they were showing us and how certain you could be of interpretations. Now on to this really intriguing Hautia-like thing. They have 6 specimens and they've got decent material, so you can see what the morphology is, more or less, but it isn't half weird. Now, Hautia has been known from the traditional Ediacara type of preservation in sandstones. And what you see is a tetraradial, 4-armed, goblet-shaped thing with what is interpreted to be tentacles at the ends of them, and the whole thing is very ridged and wrinkled in a way that is being suggested to indicate muscle. And these muscle fibres are not quite like we see in modern Nidarians, but the interpretation is that it's some sort of Nidarian. Some people have proposed a Staurozoan, but I think it's fairly uncertain where exactly you would fit this still. So what we have here is something that is very similar to it in terms of it being composed of lots of these filamentous things, these little bundles. But on the other hand, it's quite different in other ways. For one thing, it's only got 2 arms. It's not tetraradially symmetric. It seems to be having a single sort of short stalk-like thing and then opens up into this triangular sort of body with an extension at each end. There doesn't seem to have been 2 extra ones going into and out of the plane. There's no evidence for that. It looks like it was genuinely 2-armed. Now, they say Nidarians are known to be, in some cases, even in early ones, biradially symmetric rather than tetraradially. So it's plausible, but it's a striking difference. If this is part of the same group as Hautia, you don't expect to see such a radical change in symmetry within a small group. But that's not my main concern with it being interpreted as a Nidarian. Because if this is a Nidarian, it relies on these dark features, these filaments and so on all the way through it being muscle fibers. Now, muscle fibers are notoriously difficult to preserve in Burgess Shale-type faunas. They do occur. There are examples from the Burgess and Zhejiang, and we have them in Castle Bank as well. But they are not common. They're one of the most rapidly decaying organ tissues that we have. And this is confirmed by experiments on controlled decay of modern animals. And so it's very unexpected to find such good preservation of muscle tissues, but without things like the tentacles on the ends of these branches, for example. And if this is all muscle, in the Hautia specimens, in the Ediacaran type preservation, they're actually impressed as ridges, so they've not even collapsed, which is remarkable because there's nothing else that shows that type of preservation in the Ediacaran. And if this really is muscle fibers, then okay, you might get away with it. There might be ways of explaining how, for some reason, muscles are preferentially preserved under this particular type of preservation. But it gets much more difficult when you look at their supporting information, because here you have multiple specimens that are decaying. They're incomplete. They are sort of getting torn around the edges. They say they have 2 complete specimens and 4 fragments. And if you've got it broken up and decayed to the point where you're seeing fragments, that is getting suspicious. It makes me start thinking that these are not muscles at all. I don't know what they are. I don't think we have anything modern today with a similar sort of internal structure to whatever these bits of material, skeleton, whatever it is, could be. But I don't think that because of that we have to match it up with muscles, where there's a strong taxonomic argument for saying that that would actually be very difficult to fossilize in that way. If muscles are being preserved like that, then you would expect to find all sorts of other soft body things beautifully preserved. Now, it is important to say at this point that the preservation is slightly more complex than we might normally be used to, especially in these carbon film materials. So it's not just carbon. There are also a combination of iron and sulfur and calcium and phosphate in varying proportions across different fossils. But in some cases, you have some subsidiary pyrite and phosphatization going on, as well as the carbon. And this is starting to sound a little bit familiar because at Castle Bank, we see the same sort of thing, and we have an unusually high preservation chance of seeing mussels. So I'm not totally ruling out that they are mussels, but I think there is a lot of taxonomic work that has to be done to explain how exactly mussels are being preserved in this way, and whether the detailed structure of this, now we can see it in this type of preservation, actually makes sense as mussels. So, I mean, it's certainly a thing. It's certainly a weird thing. It's just that with this extra information, it actually, to me, because the differences in symmetry on a radical scale and the clarification of how it's being preserved, to me, this actually casts doubt on the Nidarian interpretation of Hautia, rather than saying, well, this is like Hautia, it must be a Nidarian. It's a weird thing. It's very interesting. I don't think that this gives us any clear link to Cambrian faunas. I think this is an Ediacaran thing. Okay, let's move on. Now we get on to the things they're calling bilaterians. This is the really novel part of the paper, the idea that we have definite bilaterally symmetric bilaterian animals in the Ediacaran. So There's a whole selection to choose from, but I'm going to start with this thing which is the only abundant animal fossil that they have. And it's an absolutely crazy thing. I love it. It's just mad. So you've got something which looks like an ecdysozoan worm, something like a priapulid, in that it's vermiform, it's sausage-shaped, it's an elongate thing, and then at the end it's got a sort of a darker bit, and then what appears to be an invertible proboscis coming out from the end of it. That's what it looks like at first glance. Then you realise that it's attached to a large sort of discoidal holdfast. What? It's a worm attached to a holdfast, and it's a discoidal sucker-like thing that is the sort of thing you'd expect for an ediacaran. So how does that work? Not entirely sure. And if this is a proboscis, which is a predatory feeding device used by priapulids, mostly predatory. Some of them use it for other things as well, like deposit feeding, detritus feeding. But you've got this proboscis which sticks out, has spikes on it, catches things, and then pulls them back into the mouth. So that's really good for an active burrower or an ambush predator and so on. But if you are attached by a sucker disc to the sea floor, and you've got this long upward pointing body with a little proboscis at the end, okay, that's a little bit weird. But fine, let's go with it for the moment. They also, as backup evidence, or the main part of the evidence possibly, apart from this invertible proboscis, have what appears to be a gut. So this is mainly seen in the supplementary information, where there are quite a few specimens showing a sort of black line running down the centre, which they're labelling as questionably a gut. The problem I have with that, and it's a pretty big problem, is that which one would you like to choose? Because quite a few of these, in fact pretty much all of them, have multiple black lines, almost identical, some stronger than others, running down the length of the body. This doesn't make a lot of sense, because things tend to have only one gut. And when you start looking for them, you can see in many of them there are multiple slightly wiggly sort of lines running down them as well. They're intermittent. Sometimes you've got two or three running parallel to each other. Sometimes they fade out in one direction and fade in another one. I imagine it's always the central one that's interpreted as the gut, because it's the one that seems to lead to the centre of the apex, which would be where the mouth would be. But if you've got multiple structures that are showing very similar morphology, similar appearance as fossils, it's difficult to interpret that as a gut. So I'm very dubious about that, to be honest. Then there are other features to consider. So near the top of this expanded sausage-shaped body, it tends to sort of widen. It's variable in different specimens. And then there's very often a sort of black line running across it. This is, again, not particularly clear what that would be. And you might look at that as the start of a band of scalids, for example, because in modern ecdysozoans, priapulids, and fossil ones in the Cambrian, you have a large number of little scalids. And having an animal like this is entirely in keeping with what we already know, because there are, well, I think there's one possible scalid has been extracted from dissolving mudstones from just below the Cambrian boundary. And there are these trace fossils, Treptichnus pedum and similar ones, from the end of the Ediacaran going into the Cambrian. And it is actually used to define the base of the Cambrian. So these trace fossils are thought to be made by priapulid-like worms. So it would not be at all surprising to have priapulid-like worms in the very latest Ediacaran, because we kind of know that they were there. But if this is a priapulid-like worm, what's it doing with a holdfast? How does that fit in? If it's got a holdfast, is it anything to do with Nidarians? What's the evidence that this is a bilaterian? it's got a proboscis, which is a feature of the ecdysozoan worms. But if this is somehow not the same proboscis, or at least if it's not an ecdysozoan feature in this case, because the thing has a holdfast, then is that suggesting that this is an independent derivation of a holdfast? Is it somewhere between the two, so somewhere between a Nidarian and an ecdysozoan on that sort of early sort of stem lineage branch of Bilateria? In that case, how would we know that this was definitely as far up the tree as to get into Bilaterians? It's a question of when these characters evolved, and we don't know enough about what the morphological evolution was between the branch leading to Nidarians and then the later branches of animals. So it's a very confusing thing to have this combination of characters. However, unfortunately, I think there is something else that needs to be very carefully considered, given all of the morphology that I can see in here, which is that in the Jiangchuan Biota, which is a much, much older, earlier Ediacaran algal Lagostata, which has some very strange things in it as well. I mean, they're assigned to algae, but in some cases we're not totally sure whether they are equivalent to modern algae in any way, or whether they're their own sort of branch of things. A lot of them are difficult. Some of those organisms have been tentatively suggested to be animals in the past, largely on the basis of features that don't really fit well into algae, even if they don't necessarily fit well into animals either. So, one of those things, or a few of those things that they have described, look very like this. You have things that look like ecdysozoan worms in having a long slender proboscis coming out of a more sausage-shaped structure. And some of them really do look a bit like these worms. They have no sign of scalids, the individual little teeth around the proboscis or the base of the proboscis. And likewise, we don't see any sign of that here either. I've zoomed in as far as I can. There's no evidence of individual tooth-like structures. It might be just the preservation just is too poor. You can't really do anything with it. Or it might be that they genuinely weren't there. So we have these things in the Jiangchuan Biota that are similar in that way. They also don't look like they are very close to ecdysozoan worms, but some of them do have this weird proboscis bit sticking out. Okay. However, there are others which are quite different, where it looks like there is an axial structure running up through the middle and out the top of a more conical-like outer part. And this outer part also has, in many cases, longitudinal lines going down it. They have a little holdfast. There's a gradation between this and this thing that looks more like a worm. And then there are a whole range of other things which are not similar in the same way. They don't have this bit sticking up the middle, but they do have other features which are more similar. So these longitudinal thickenings or rods or something going down this conical structure. And these are widely assumed and believed to be algae of some sort. And then you get this gradation of weirder things with this central, fainter thing sticking up from the middle, which have theoretically been interpreted as animals, but nobody is really claiming that they definitely are animals. I think the general assumption is that they are weird algae in some form, relatives of these other things. So these already exist in the Ediacaran of China. And I am not at all convinced that what we're seeing here is any different to that. So is there actually evidence that these are animals at all, let alone bilaterians? The sort of evidence you'd want would be details like actual scalids, things that we can tie in because of their detailed structure to the sort of scalids that we get on the later worms. You might want to actually see internal structures like a gut, which we're not seeing at all. You might want to see a lack of a holdfast. If this is a bilaterian, which generally assumed to be mobile organisms, what's it doing with a holdfast? A lot of things are secondarily sessile, but that would mean that this has already gone through this previous mobile stage of evolution and has developed a holdfast, which is difficult to argue given how little else we know about it. So one other thing that the authors say is that there's a lot of variation in the proportions, in the width to length ratios of these things, and that this indicates a degree of contractibility and flexibility that you don't get in algae. However, what algae have instead are variable morphologies. And we ain't seeing any of these doing any contracting. We're just seeing slightly different shapes. We don't know that one is a contracted version of another one and was originally identical to it. We just know that they are now preserved as slightly different shapes. So that's slightly awkward. I don't think that's a good argument against it being something like one of these Lanchen-type algae. The other thing is that they're arguing that the proboscis is retracted in most specimens. You don't see it in most of them, but you'll notice in these that the proboscis is much fainter where it's preserved in these ones that they're illustrating than the rest of the trunk. So how much of this is a taxonomic effect? In many cases, they're only apparently seeing the anterior, the top, the apex of the body part, and then it fades out. So in those cases, I would be quite willing to suggest that, in fact, it was there, it's just not preserved. It's something which decayed more quickly. And likewise, different lengths, well, they're illustrating two of different lengths, but they're not that different, and one of them seems to be going off the slab. So I don't know if that is partly retracted. That's what it seems to be suggesting in the captions. So there is so many difficulties with this that I am not happy taking that as evidence for a bilaterian, because I think it's not even an animal. Sorry about that. It does get better, though. I'm slightly surprised to find myself saying that I like this one more. It's a single specimen. It's a weird, sinuous, sort of sausage-shaped thing, and it's not even perfectly complete. The end is missing by the looks of it, and there's a crack running through it, and it doesn't have vast amounts of detail, and it's described as a sausage-shaped vermiform organism. Possibly, they think, even a scalidophyran worm, one of these ecdysozoans. And what's the evidence for that then? Well, they claim that there is a possible gut, which is this sort of darker band running down the centre. Now, I'm not convinced by that, because there are darker bands either side as well, separated by lighter bands. I don't think you can say that it is well enough defined to be able to do much with it. So not happy with that as a gut. But there are a couple of features here that I do like. And one is they do highlight that this end here, where you're seeing the complete end, seems to have a circular structure in the centre which almost looks like a mouth. Possibly a circular opening. Now, with a lot of sort of squinting, I can also make out potentially radiating structures pointing inwards from the edge of that mouth. And around the edges, this thickened carbon bit, you could see them being little bits of scalids poorly preserved, possibly. I'm really not confident about any of that at all, but I can see what they're getting at. If this is some sort of very early ecdysozoan type worm, or precursor of ecdysozoans even, but some sort of ancestral vermiform organism, then having a central mouth there with some sort of structural modifications in the form of tooth-like structures, scalids, would make a lot of sense. There's not enough there, certainly in one specimen, to be sure that's what you're looking at. I am not confident that that is real. If it was, say, a one of these sort of sinuous algae cylindrical things with a little shorter or narrower holdfast section or stalk at the bottom, that could be equally well the scar where a stalk was attached. So I'm not happy with that, but it's certainly an intriguing one. And the one other aspect that I really like the look of is the way that it curves. I mean, this doesn't sound particularly sort of scientific, but it seems to have a pretty even type of curvature. It's not folded, it's not sort of crumpled over itself. It just seems that there is a consistency here which was dictating how far it could bend over a short distance, and that gives you this sinusoidal curve. Now, the reason I like that is that there are quite a few worms, particularly in the ecdysozoa, whose muscle arrangement tends to lead to that sort of curvature. If you think of nematodes, for example, obviously they're much longer, thinner proportions in general, but they tend to generate this sort of sinusoidal type arrangement. Priapulids are often sort of curved into semi-loops like this. Normally just the one rather than curving back on itself, but hey, it's Ediacaran, we'll give it some leeway. So in this case, I'm actually intrigued. I like that one. I don't think with one specimen you can say it's definitely a bilaterian. I don't think you can rule out other alternative interpretations like certain types of preservation of algae. But it's certainly intriguing. And that one, yeah, I want to see more of that. Please, can I have some more? The rest of it is where it starts to get really juicy, because we're not just talking about bilateria here, but potentially about deuterostomes and in particular hemichordates. Yeah, that's getting quite high up the evolutionary tree at this point. So the first thing is we have a couple of specimens illustrated, there's 4 in total apparently, of these tubes with quite distinctive elongated windows running through them, which look like pretty good candidates for Margaritia. Now, I note that they're not being totally adamant that it is Margaritia, but it looks like it. Now, Margaritia is known from the Burgess Shale and elsewhere, but what actually is it, is the question. So it was long regarded as an alga, and then some Oecia worms belonging to the Entranus, or acorn worms, a group of hemichordates, were found inside some of these specimens. And so the consensus now has shifted towards them being probably secreted by Entranus worms. But I don't know. That may not be the last word. That's all I can say, because I'm aware of some other research which isn't mine. But this is something which, at the moment, we have to take this slightly with a pinch of salt, because there's only this one line of evidence suggesting that these things were made by Entranus and that these are indeed Margaritia itself rather than something convergent. But it looks very interesting. But the last ones are the most intriguing of the lot, and for me the most unexpected, because these seem to be Cambroernids. Now, some of my members will be aware of what Cambroernids are, because we've been talking about things like Herpetogaster and Phlogites recently. And these appear to be Herpetogaster and Phlogites, or at least something very similar to them. Now, I grant you, they look like them. The structures that are visible are pretty convincing, at least at first glance. There are anomalies, and there are things I'm not quite happy about. So I'll go through those as well. But yeah, at first glance, this looks like Phlogites, which is a thing with a stalk coming out the bottom, a sort of a globular body, and then some short tentacles coming out the top, which are not preserved. And Herpetogaster, which is more of a curved tubular structure with a stalk coming out from the side, almost halfway along, or near the lower end, and then an array of tentacles which are branched in a very distinctive way coming out from the apex. But this sort of curved sausage-shaped thing with a stalk coming out from the lowest point is a very distinctive feature of Herpetogaster, which is known from now multiple continents in the Cambrian. So why am I not certain? Or why am I not wanting to say I'm 100% certain? There's a few little things. So there are actually multiple specimens as well. Well, there's only one Phlogites and 3 Herpetogaster, they say, or Herpetogaster-like. So why am I not certain? Or why am I not willing to say that I 100% agree that that's what these are? A few reasons. Firstly, the various different specimens of the Herpetogaster-like thing are not, to me, convincingly the same thing. So you've got the one very well preserved one which seems to show this sort of loopy structure, the curved body. Fair enough. But then the other two are less convincing. There's this one which has a very different shaped stalk, which is sort of widening into the body, like it does in Phlogites, but it doesn't seem to show the sort of the bent sort of semicircular sort of structure, shape of it, and there's no sign of tentacles. You could argue that was a different orientation, but again, I'd hope to see at least the tail end of it bending up again, and I'm not seeing any evidence of that at all. The other one, you've got a slightly distorted thing, which looks like this one I just mentioned, but has possibly a stalk at one end and a tentacle of at the other, but it's actually, both of them are poorly preserved. Could that be a tentacle of A? Maybe. Could that be a stalk? Maybe. It's not quite like the one that looks like Herpetogaster. These two specimens could be their own thing, which is, again, related, but what you've got here is a little stalk with a carbonaceous blob on it, and given that this place is full of algae, which include things like the longfang shaniids, which have a little stalk with a carbonaceous blob on the end, I wouldn't like to rule out those being some sort of variation. What you really need to see to say that you've got definitely Herpetogaster-like Cambroernid is the tentacles, I think. Because they have a very distinctive structure apart from anything else. They're multi-branched in a way which is quite distinctive. You have little clusters of branches with sort of subdivided branches coming off them at various points along the main axes. And do we see a trace of that in this specimen? The good one, I mean. Well, kind of. You've got these very short tapered tentacles, and they might be sort of multi-branched, but the authors say that there is minimal evidence for branching in these, which is slightly problematic. Another feature I don't really like is that the stalk branches. Now that could be seen as something really interesting, but you've got a definite little branch on that stalk. So is this actually colonial? Is this a single individual from a colony with multiple ones joined together? That wouldn't be too surprising given that terebranchs do that, but their ancestors apparently didn't. So maybe there was a tendency to become colonial, or maybe they somehow started out colonial in the ancestors of deuterostomes. But that would again be surprising because we don't see any evidence for ancestral coloniality. So I'm not totally sure what's going on there. The other thing that I am slightly unhappy with is that there appears to be a sort of colour stain linking the top of the two ends of this arc. Now, it's quite weak and it might not mean anything in particular. But when you look at the Phlogites, you see something very similar. The area between the two arcs of this rounded structure is actually coloured. It's sort of, there's iron oxide there. It's of a similar sort of depth of colour to the stalk. The actual outline looks like it might have a sharp edge between them, as if this is a cup-shaped thing with a loop just going along the bottom margin of it. With the Herpetogaster, it's not so obvious, but there's only the one specimen which shows this loop, and I don't know. I'm slightly concerned that this could be incomplete preservation of something which had a sort of carbonaceous loop around the bottom, and then there was soft tissue over the rest of this, which would make this less like Herpetogaster. Possibly more like Phlogites. If this is, say, the digestive system, you could interpret it that way round. That, for example, in these other Cambroa, Discophyllum and the Paropsonemids, you do have a curved gut like this. So that could actually be the digestive system, which is the only really clearly visible part of the soft tissues, and it was surrounded by this sort of other soft tissue which is poorly preserved. I wouldn't rule that out at all. I'm just left with these little anomalies that make me slightly unsatisfied. That said, overall, it looks very good indeed. This really does look like it could well be deuterostomes, stem group, ambulacrarians, which is exciting. Because although we don't know how far below the base of the Cambrian it is below the base of the Cambrian. And this is a time after even some of the tubular fossils have declined. So it's late in the Ediacaran, very late. But this is exactly the sort of time, if we read the fossil record at face value, we would expect the first recognizable groups of crown group animals, aside from the Nidarians, and maybe one or two other of the early branching radiate things, but the first recognizable bilaterians we would expect to be seeing around now. And maybe, 90% maybe, that's pretty good for me. Maybe that's actually the case. We might be seeing some of the early branches of the deuterostomes. Is this actually stem group ambulacrarian, or does it go further back down the deuterostome tree? Is it stem group deuterostome? That I don't think we can say. We need more information about how the morphology of the deuterostome groups evolved from their common ancestor. But it's a really, really interesting thing. So where does this leave us overall? We've got a really, really interesting new assemblage of fossils, semi-new. These are individual fossils that are extremely rare, which have turned up during long-term collecting of algae and other things. It looks like the new site that they're working on may be slightly more prolific, but it's certainly a wonderful, interesting assemblage of fossils. And I particularly love that little thing that looks like an ecdysozoan worm on a sucker. It makes no sense from that point of view, and I think it's probably one of these weird algal-like things you get in Lanchen, but I love it anyway. But these things that appear to be deuterostomes are actually quite compelling, and I also like the look of that possible worm. Other things in the paper, less convinced by. Ctenophore, and not very happy with that one. But there is enough here that this still is one of the things we've been looking for. It's a very low-grade Burgess Shale-type fauna, if that's what it is. We're not seeing the fine detail that you would hope to see. I mean, for example, we have Cambroanids in the Castle Bank biota, which show quite a lot more fine detail than is visible here. And we've been worried about whether they're convincing. They're a lot more convincing than these are, but still, it's a question of degree and how important it is for it to be right. And in this case, we're talking about the earliest evidence for deuterostomes. It's got to be pretty good. And I don't think it's quite there yet for certainty, but it's getting there. That's nice. And possibly one of these little worms that is responsible for these early Treptichnus type trace fossils. If that can be assigned to these trace fossils, that is absolutely brilliant. But we need more specimens for that one, even to prove that it is definitely a worm. Okay, this is a very short format paper. There's not the huge amount more information in the supporting information either. It's in Science, so that's kind of what you'd expect. It's a preliminary paper. I will await with great interest the individual species being described in future papers with much more detail, much more detailed discussion, much more citation of the previous literature, so stuff like the Lantian thing for comparison. And I'm going to reserve any further judgment, I think, until then. I think this is a fabulous new assemblage. I think that some of it has been interpreted more towards the animals than it should be, but others, yeah, consider me intrigued. For now, though, I think that's all I've got for you, which is probably a relief because it's gone over an hour. Amazing. Right. Thank you for sticking to the end, those who made it, and I will be back with something, probably something interesting. You never know. Sometime soon. Bye for now.